This is a good-looking crowd out here tonight. Well, today. I'm Alvaro, and our capstone is prediction algorithm using network statistics.
And my name is David Gia.
And I'm David Keller.
Our mentors are Dr. Glenn Bruns, Peter, and Dusan. So, have any of you guys used QuickBooks or TurboTax? Oh wow, I'm surprised. Good for you guys, good for you guys. Anyways, so right now Intuit is looking for an efficient way to detect any fraudulent accounts. So what they want to do is, they came over, asked us, hey guys, we want to find a way to implement accounts and to find create an algorithm to detect fraudulent accounts. Well, our project does that. By the year 2020, the global cost to repair fraudulent account damages could reach up to $31 billion. I believe this project has the potential to reduce that cost.
So in this picture, you can see the circles actually represent accounts, and the lines represent similarities between accounts, such as tax bracket, age, location. So our algorithm will look at these lines and create and delete connections by using a filter and a set of criteria. Once these this new graph is created based on the filtering criteria, we will then analyze it and use that to make predictions about if a node is fraud, such as this red node right there.
As for the approach to our project, first we couldn't use Intuit's data because it contained sensitive client information. So we had to find our own data set which had a similar data structure to their data, and we settled on a data set on speed dating. Now, how we use the speed dating data set, rather than using it to find like fraudulent people in speed dating, we use it to predict whether someone have a match or not at a speed dating event, and that was kind of similar in a way that we can use it to, in Intuit's data, how you can find a fraudulent account. Now, after we got our data, we used RStudio to apply the filter that David Keller mentioned, and we created new graphs based on these filters, and these criteria can be anything such as only connect people if they work in the same occupation, or they're the same race, or there's a certain age difference between them. And by doing so, we can look at these new graphs and gather information such as the average age of each of these graphs or the average income, and use that information to make our predictions. As an example, the left is an unfiltered graph that only shows connections between people who met at a speed dating event, while the graph on the right shows connections between people who met and are of the same race. Now, this can be applied in Intuit's case, such as their TurboTax software, as, for example, maybe the graph on the right would show people who are within the same income bracket, and maybe using these graphs, we grab the average tax returns, and we might find that one person in the graph might have a tax return that's way above their average, and that makes them an outlier and potentially a fraudulent account or a suspicious account. And in summary, we had to find our own data set because we couldn't use Intuit's data. We applied a filter based on criteria in that data, and using the new graph that we made because of the criteria, we made predictions based off of that.
We would like to thank our faculty mentor, Glenn Bruns, and our class professors, Satya and Paige. And then finally, our industry mentors, Peter and Dusan.